So, good morning, everyone, and we are into lecture number 5 in wave optics, and we will be dealing with polarization in this particular lecture. And with this, we will finish the entire wave optics as such. Well, just to give you a quick recap of what we had done in the previous classes. What we have done in the previous classes, we have dealt with interference and we have dealt with diffraction. Yes or no? And I hope you recollect things about interference and diffraction, isn't it? Tell me. Okay, the mic is gone. Mic is still there.
There,
There,
sir.
there. Okay. Remember those points about diffraction and interference, the difference between the two. In interference, we have just two slits and two wavefronts from two different coherent sources are coming and they are getting superimposed. Whereas in diffraction, there is just one slit and we have superposition from sources from the same wavefront. The other thing that is different is in case of maxima for interference, path difference is n lambda. But for diffraction, it is 2n plus 1 lambda by 2. And remember, the intensities of all the bright fringes are not same. In fact, the central bright fringe is having the maximum intensity, and as you go farther away, the secondary bright fringes, they are having less and less intensities as we move forward. Same with fringe width. The central fringe, the central bright fringe. How much is the fringe width of the central bright fringe? Tell me. What is the fringe width of the central bright fringe in diffraction? How much is that? Do we remember this? We have not noted it down. It is 2 times of beta 2 times d lambda by d, where d, capital D, is the distance between the slit and the screen. Sometimes in Fraunhofer diffraction, the focal length of the lens is given, so you can replace capital D by F. In some cases, the small d can be written as A, where A stands for the width of the slit. Do we remember it?
Yes, sir.
Well, why could not you answer it then, if you remember it? Well, I've also done what? I have also sent you the mind maps for this. Did you see those mind maps? Yes or no? No or yes?
Yes, sir.
Okay. Your yes sir is not coming with a lot of conviction. So I understand that you probably have not gone through it. You were very keen to get those get those mind maps, but I don't think that probably you have seen those mind maps as such. What we'll do is once we are finished with polarization, I will show you the mind map of the entire wave optics. This is just in one sheet. We will try to cover everything from that particular mind map. So I will just open it up and keep it so that after dealing with your polarization, I can show you the mind map and show you whatever things we have discussed are already there in the mind map. So whenever you want to revise, I don't know how much time you are left with to revise. You can go through those things. Remember, if you still need anything, please feel free to ask me. I'm there to help you out. Whatever you need, whatever you have not understood, please feel free to ask for it. Okay? Don't
Okay.
feel shy. Whatever you want. If you want any help in anything, let me know.
Okay, sir.
I will help you out in whatever ways I am possible and whatever ways it is possible. Okay? So now let us move on and see what are we supposed to do today. And the topic for today is polarization. Have you heard about the term polarization anywhere before? Have you heard about the term polarization?
Sir.
What do you, yes, then tell me, what do you think is meant by polarization?
So we just know topics, sir, but we don't know concept.
You understand the topic, but you don't know it? No, not a problem. If you don't know it, there is nothing to be ashamed of. I do not know a lot of things in life. I do not know what is quantum physics. Does that mean that I should be ashamed of myself? No, I should not be ashamed of myself. You don't know it? Not a problem. That is why I'm here. And that is why you are in the class. Polarization. Now, what do you understand by the term polarization? Now, you understand that light is an electromagnetic wave. Yes or no, beta?
Yes, sir.
Light is an electromagnetic wave. So, basically, it consists of electric as well as magnetic fields. Do we understand this?
Yes, sir.
Now, this electric as well as magnetic field, out of those electric and magnetic field, this electric field is very strong compared to the magnetic field. So even though light consists of both electric and magnetic field, you will find that in most of the discussion here in polarization, we would be dealing with the electric field vector or electric field rather than the magnetic field. And the simple reason is that the electric field is very strong, very large as compared to the magnetic field. Do we understand this?
Yes, sir.
Now, even if you have a single source of light, a single point source of light, now this point source of light, when it produces light, this light wave is emitted by each and every atom of that point source, and therefore they are free to emit their own photons and their own waves, and therefore this electric field ka vector, and I'm not talking about the magnetic field, this electric field ka vector can be in any particular direction. Normally, what happens is, if I show you a diagram from a different sheet, I can't send you more than one sheet because that is going to create a lot of trouble in your head. That is why I've just sent you one sheet and I'm going to show it from another sheet of mine. And I hope that you can see it and draw it to understand it. Okay, so this is a diagram taken from one of the other sheets. Do you see this diagram? Do you see this box here?
Yes, sir.
Now, what do you understand what is there in the box? Now, if I could magnify the image of this box so that I can show it to you. Let us just see this box. Now, what I'm talking about here is only the electric field, and I'm not talking about the magnetic field. Now, what happens is, this is the direction of propagation of light. Both this electric field and magnetic field, they are perpendicular to the direction of the propagation of light. Do we understand this? Three perpendicular direction, X,
Sir.
Y, and Z. Do we understand this?
Yes, sir.
Now, if your light is moving in the direction of X, your electric field and magnetic field will be in the YZ plane. Do we understand this?
Yes, sir.
So this is your x-axis along which your light wave is moving, and this is your YZ plane in which your electric and magnetic fields are supposed to be there. Now I'm not talking about the magnetic field. Let us only concentrate on electric field. Remember, all these three directions are perpendicular. If light is moving in this direction, it may happen that the electric field will be in this direction and the magnetic field will be in this direction. Do we understand this?
Yes, sir.
So all these three are mutually perpendicular, but right now I am not talking about the magnetic field. Let us only concentrate on the electric field, because electric field is very strong as compared to magnetic field. So light is propagating in the x direction. Your electric field can be in the YZ plane. As you can see, there are all possible infinite directions in which your electric field can be directed. This electric field can be directed in any direction which is perpendicular to the x-axis. That means any direction in the YZ plane. Such type of light, which is the normal light that you see in my room, in your hostel, in your classroom, that is known as unpolarized light. Do we understand this?
Yes, sir.
This is your normal light, or this is known as your unpolarized light, and this is the definition that you can write. You can also, there is a definition in the sheet as well. We will discuss that, but this definition is more precise, and therefore I would ask you to write this definition apart from the definition that is given in your sheet. Unpolarized light, the light having electric field oscillation in all directions in the plane perpendicular to the direction of propagation of light, is known as unpolarized light. Now, this oscillation may be resolved into horizontal and vertical components. Do we understand this? So,
Yes, sir.
light is moving like this. Can you see this? The direction of pen is the direction of motion of light. Oh, not the motion of light, direction of propagation of light, and your electric field will be in this plane. Now, in this plane, you can resolve it in the horizontal direction and the vertical direction. Do we understand this?
Yes, sir.
So this type of light, which is your normal light, is known as unpolarized light. Here they have resolved it. As you can see, this is the direction of propagation. This is the vertical oscillation, and they have shown dot. Dot means in and out, dot means out, cross means in. So your electric field, one component is like this, in and out, in and out, in and out. The other component is up and down, up and down, up and down, and your light is moving like this. Do we understand this? All these three are perpendicular. That means your light is moving like this, propagation is like this, your vertical component is like this of electric field, and your horizontal component is like this. Do we understand this?
Yes, sir.
I'll give you a minute to write the definition of unpolarized light. Okay then. So that is what we have done till now. Light propagates as EM waves. E stands for electric, M stands for magnetic. The magnitude of electric field is much larger as compared to the magnitude of magnetic field. So we therefore describe light as electric field oscillation. If light is moving in the x direction, the electric field will be anywhere in the YZ plane. You can resolve it into two directions, vertical and horizontal. This type of light, where electric field can go in any direction perpendicular to the direction of propagation of light, is known as unpolarized light. Then the name of this chapter is polarization. So if the name of the chapter is polarization, then we must understand what would be polarized light or plain polarized light. Now, can anyone guess what is polarization of light from what we have discussed till now so far? Can anyone tell me what would be polarization of light? Yes, I'm waiting. Can you now guess what would be polarization of light? Well, you can't. Let me help you out. What will be a plain polarized light? If somehow using something, we can confine the vibration of the electric field in only one direction, which is perpendicular to the direction of the wave, the light. This light is said to be plane polarized light, and the plane containing the direction of vibration and the wave motion is known as plane of polarization. If I can do something so that I can restrict or only allow electric field to move in only one direction, remember it is moving in all possible direction, it can be moving in all possible direction. If I can restrict electric field in only one direction, which is perpendicular to the direction of the wave. For example, the wave is moving in x-axis. If I can make something happen so that electric field is only along y-axis or electric field is only along z-axis and it does not have any other component along any axis, we will call such light as plane polarized light. Do we understand this? Plane polarized light is on your screens now. And what it means is, if somehow we can confine the vibrations of electric field in only one direction, which is perpendicular to the direction of wave motion, then this light is known as plane polarized light, and the plane containing this direction and the direction of propagation is known as plane of polarization. Do we understand this?
Yes, sir.
I'll give you a minute to note this down. What is plane polarized light? Plane polarized light. Have you noted it down, beta?
Yes, sir.
Okay. Now we have to, whatever we are writing are all important points and they can appear in your exam as it is. Now the second point, the first point is all about what is plane polarized light. The second part is about what happens if an unpolarized light is converted into plane polarized light. what happens to the intensity? Remember, very important point. The intensity reduces to half, and we will understand. We may not understand because I don't want you to waste your time on understanding this. Remember, whenever the unpolarized light is converted into plain polarized light, the intensity becomes half, or the amplitude becomes A by root 2. Remember, intensity is directly proportional to amplitude square. Amplitude becomes 1 by root 2 times, and therefore intensity becomes half. Can you remember this? Polarization again is a very convincing proof of wave nature of light. These three phenomena, what are the three phenomena that we have read in this chapter? What are the three phenomena that we have read in this chapter? Tell me, what are the three phenomena? Phenomenon. Tell me that we have read, which are proof of wave nature of light. What are the three phenomenon we have read in this chapter that are proof of wave nature of light? Do we know this?
Diffraction, interference,
What?
polarization.
I can't hear you, beta. Tell me again.
Diffraction, interference, polarization.
Interference, diffraction, and polarization. Remember, the name of this chapter was wave optics because only wave optics or wave nature of light can explain these three phenomena: interference, diffraction, and polarization. I'll give you a minute to note this down. And we carry on with noting important points. Remember, all these points are potential question, and this is not given in your sheet, so please note it down.
Okay, sir.
The light having oscillation only in one direction, is known as plain polarized light. Point number one. Point number two, the plane in which oscillation occurs is known as the plane of oscillation. Remember, the plane of oscillation is the plane. Let us say, for example, and I am giving you a very simple, smart example. Let us say that the light is propagating in this direction along x-axis, and your electric field, the vibration, is along y-axis. What is your plane of propagation now? The light is propagating along x-axis and electric field is along y-axis. Your plane of propagation becomes the xy plane. Do we understand this? That is
Yes.
known as your plane of oscillation. Then there is something known as plane of polarization. This is the plane which is perpendicular to the plane of oscillation. So xy plane is your plane of oscillation. Any plane which is perpendicular to it, yz plane, will be known as your plane of polarization. Do we understand this?
Yes, sir.
Now, how can you polarize light? Light can be polarized by transmitting it through certain crystals such as tourmaline, or devices known as polarites. You might have heard this term Polaroid camera and all those things, right? So if you want to create a polarized light or a plain polarized light, you should be transmitting light through certain crystals like tourmaline, or passing it through devices known as polarites. I'll give you a minute to note it down and then we will move further ahead. We can create plain polarized light with something known as polarites. Now this term may sound very confusing, very hep, but it is a very simple thing. Now instead of telling you the definition. Look at this diagram. Do you see this diagram? So it basically consists of, you can see in very simple sense, let us see, we have a cardboard and you cut one perpendicular slit. This is a piece of cardboard and you cut, let us say this is one line, one slit cut on the cardboard. And if you allow light to pass through this cardboard, what will happen is only light parallel to this slit that I have cut will pass through. Do we understand this?
Yes, sir.
A plain cardboard, and I've cut a slit in that cardboard and I allowed light to pass through. This cardboard will block everything. It will only allow the light which is parallel to this slit passing through this slit to pass through. You can call that light as plain polarized light. And this is what a polarized does. You can see there are cuts here. These cuts are nothing but their optical axis. Do we understand this? Only light which falls on that axis will pass. The only vibration, the electric field which is parallel to that axis will pass. Apart from them, everything would be blocked. Do we understand this?
Yes, sir.
So here we have unpolarized light. Now this unpolarized light, what I have done, this is unpolarized light. This is the direction of propagation of light. Do we understand this?
Yes, sir.
And here are the direction of electric field. One electric field, the vertical component is here and the horizontal component is shown by this dot. Do we understand this?
Yes,
Because this electric field is in the YZ plane, it can be resolved like this and resolved like this. Now what we do is we put a Polaroid which has the optical axis vertical. So what happens? All these horizontal things, all these dots, all these horizontal components, they get cancelled. Do we see here? There is no dot here. Do we see this?
Yes, sir.
There is no dot here. That means the horizontal component has been absorbed. It's no longer there. And this light only has propagation along x-axis, which is the direction of light, and it only has electric field along the y-axis. This light becomes my plain polarized light, and this device becomes your Polaroid. So what is a Polaroid? It's a device used to produce plain polarized light. It is based on the principle of selective absorption and is more effective than a crystal of tourmaline. It basically consists of a thin film of ultramicroscopic crystal of quinine sulfate. You must remember this name. And their optical axis is parallel to each other. So what happens? Only electric field which is parallel to the optical axis will pass. Any other component will be absorbed. As you can see, the dot, which is the horizontal component, has been absorbed and only the vertical component is passing through. The light on the right hand side after the Polaroid is known as plain polarized light. Before the Polaroid, it is unpolarized light. Do we understand this?
Yes, sir.
One more thing you must understand, on the blue side, if the unpolarized light is having intensity of I and amplitude of A, let me call it as I naught and A naught. On the left hand side, when the intensity of the unpolarized light, the blue light, is I naught and the amplitude is A naught, what will be the intensity of the polarized light? And what will be the amplitude of the polarized light? I have already told you that. What will be the value? Unpolarized light, the intensity is I naught. What will be the intensity of the polarized light?
A by root 2.
Intensity will be I naught by 2 and amplitude will be A naught by root 2. Do we understand this?
Yes, sir.
So all the information of what is a polaroid, how polarization happens, what is unpolarized light, what is polarized light, how it is getting polarized, what is the intensity before, what is the intensity after, what is the amplitude before, what is the amplitude after is given in this slide, this section. Please note it down. I will give you time to do that. Then we move ahead to the next diagram to understand what is a polarizer and what is an analyzer. Now, just don't get confused with the terms. Both are same actually. First of all, we need to understand that polarites allow the light oscillation parallel to the transmission axis. All these terms you must remember. Transmission axis. Now look with your eyes wide open. You see two diagrams on the left hand side and on the right hand side. Now based on what you have understood, can you tell me what is the transmission axis of this P? P means polarizer and A means analyzer. Do you see their transmission axis?
Yes,
Can you
sir.
tell me which is their transmission axis? See, the vertical lines along which only vertical electric field is passing is the transmission axis of this polarizer. Do we see this?
Yes, sir.
Those are the transmission axis. For this analyzer also the transmission axis is parallel. These two axes are parallel to each other, right? For the polarizer as well as the analyzer, both are having parallel transmission axis. Do we see this?
Yes, sir.
In case number 2, you have polarizer, the transmission axis is vertical. Do you see this?
Yes, sir.
But for analyzer, the transmission axis, I have rotated this analyzer by 90 degrees. So now what will happen? It will absorb everything in the vertical direction and there will be no light here. Here the transmission axis has become horizontal. Do we understand this?
Yes, sir.
Now, so to understand what is a polarizer and what is an analyzer, the crystal or the polaroid on which unpolarized light is incident. The first polarizer, the first polaroid is known as polarizer. So this polarizer, what it does is it converts unpolarized light. This is unpolarized light. And this polarizer converts this unpolarized light into polarized light. Do we understand this?
Yes, sir.
What happens to the intensity? Again, repeat. What happens to the intensity? If the intensity is I here or I not here, what will be the intensity on the right hand side of the polarizer? The intensity on the blue side, left hand side of the P stands for polarizer. Intensity is I naught. What is intensity on the right hand side? It will be I naught by 2. Do we remember this?
Yes, sir.
Now we have an analyzer as well. Now this analyzer is having transmission axis same or parallel to each other. So the entire polarized light will pass through, nothing will get absorbed. So if I talk about the green light, which is the light coming out of this analyzer, the intensity of this light will also be equal to I naught by 2, which is same as the intensity of light coming from the polarizer. Do we understand this? Why is this happening? Because both the transmission axes are parallel. Now, if I ask the same question here, this is unpolarized light here, U, ordinary light. If the intensity of this light here is I naught, what will be the intensity after the polarizer? What will be the intensity after the polarizer? It will be equal to I naught by 2. Do we understand this?
Yes, sir.
What will be the intensity after the analyzer? Here I am not getting any light, so the intensity becomes 0. Do we understand it?
Yes, sir.
So whenever we are trying to polarize a light, we normally use two polarides. The first polaride is known as the polarizer. The function of the polarizer is to polarize the light. If the original intensity is I naught, it will make it to I naught by 2. After this, we put another crystal or another polaride to check whether the light has been polarized or not. It is checking whether your light is polarized or not, and therefore it is known as analyzer. It is analyzing whether your light is polarized or not. The first one, P, is known as polarizer. The second one, A, is known as analyzer. Do we understand this?
Yes, sir.
I'll give you a minute to note it down.
Okay, sir.
Then a small reminder that when unpolarized light is falling on a polarizer, and I keep on telling you this every now and then. Where is my pen? Keep on telling this every now and then. When unpolarized light is falling on a polarizer, the intensity becomes half. Remember that unpolarized has intensity I, then the polarized in light will have intensity I by 2. Do not forget it ever. Then comes the next heading, and it's a very important thing, the most important thing of this chapter. There are two laws that you must understand. The first of these law is known as the Malus law. The second one is known as the Brewster law. The first heading that we are going to write is the Malus law. And now it is very evident. We have already seen one example. Now see, the first one is your polarizer. Do we see the polarizer here? The first polaride is the polarizer. Now, the intensity of the original light is given as I1. The intensity of the original light is given as I naught. After the polarizer, the intensity becomes I naught. So they have used different terms for this. You can understand the relation between I1 and I naught. Yes or no? You understand the relation between I1 and I naught? I naught will be equal to I1 by 2. I have said that repeatedly over and over again. Yes or no? Now what we are going to see is relation between this I naught and this I. Now this I is the intensity after polarization. So let me, after the analyzer, so let me use that green pen here. So I is the intensity after the analyzer and A is the amplitude after the analyzer. I naught is the intensity after the polarizer and I is the intensity after analyzer. And you can see one very particular angle here, this angle theta. What is this angle theta? This angle theta is the angle between the plane of the polarizer or the transmission axis of the polarizer and the plane of transmission of the analyzer. Do you see? This is the plane of transmission of analyzer and the straight one is the plane of transmission of the polarizer. Do we see this angle theta?
Yes, sir.
Analyzer, polarizer is kept like this, analyzer is kept like this. The angle between the two is known as the angle of transmission. What does this Malus law say? This law states that the intensity of the polarized light transmitted through the analyzer varies as the square of the cosine of the angle between the plane of transmission of the analyzer and the plane of the polarizer. So basically it is saying I, which is the intensity after the analyzer, will be equal to I naught into cos square theta. Do we understand this? This is the relation between the intensity after the
Yes, sir.
analyzer and the intensity before the analyzer. This law is known as Malou's law. I'll give you a minute to note it down. Remember, here we are finding a relation between intensity after the analyzer and intensity before the analyzer. Before that, we had find out the relation between intensity after the polarizer and before the polarizer. Before the polarizer, intensity was I1. After the polarizer, intensity was I naught. I naught was I1 by 2. Now I'm finding the relation between I naught and I. I naught is the intensity after the polarizer. I is the intensity after the analyzer. I will be equal to I naught into cos square theta. I'll give you a minute to draw this diagram and note it down. Let's move ahead and let's see some examples of different angles. We have already seen this angle. I will be equal to I naught cos square theta. Yes or no? Please raise your hands. Where I is the intensity after the analyzer and I naught is the intensity before the analyzer. If I write it in terms of amplitude, the amplitude after the analyzer will become A naught cos theta. Very important point. Do we understand this?
Yes, sir.
Now different case. Case number 1, if angle theta is 0, if angle theta is 0, case number 1, intensity remains same, amplitude remains, and I told you in the diagram there. Yes or no? Do we remember this diagram where the angle was 0?
Yes, sir.
See, I again showing you this diagram. I hope you can see this. Here the angle between the between the polarizer and the analyzer is 0. Do we see this? Yes or no?
Yes, sir.
And here we see the angle as 90 degrees. If you put it in the formula, the intensity will become 0. Do we understand this? Yes or no?
Yes, sir.
Well done, sir. Let me move forward. So this is the case. The first case was angle was 0. And the second case was angle was 90. Do we remember those two cases? I just showed you a glimpse of those two. Yes or no?
Yes, sir.
The third case, just a general case, if I put the angle as 45, the intensity becomes I naught by 2 and the amplitude becomes A naught by root 2. Remember, remember the relation between I naught and the original intensity is half. I, capital I into small I is the intensity of the unpolarized light. Therefore, the intensity of the polarized light becomes I by 2. So the value of I naught is I by 2. Therefore, the actual formula in terms of original intensity looks like this. Do we understand this or this is getting confusing? I, or you can write it as I1. I1 is the original intensity of the unpolarized light. So I naught becomes I1 by 2. And in the formula, you can put I1 by 2 in place of I naught. Raise hands will give me more confidence that we have understood this.
Yes, sir.
Okay, I'll give you a minute to note it down. Now is the time to note down one more formula, and remember this formula, you will not find it in other books. Percentage of polarization. Sometimes they ask you what is the percentage of polarization. So what do? You find the maximum intensity that is coming out minus the minimum intensity divided by maximum plus minimum multiplied by 100. Whatever you get will be known as percentage of polarization. Hardly you might get the question on this, but if you get, well, you will be the only one who knows this formula and you will be getting 4 marks out of this. So you can note this down. I'll give you a minute to note it down, which is known as your Brewster's law. Now, what happens in this Brewster law, I will try to make you understand by this diagram that is given in your sheet. What you see here, the blue one is UPL. UPL stands for unpolarized light. Do we understand this? So what is happening is this unpolarized light is falling on the boundary between two mediums. Some part will be reflected and the other part would be refracted. Do we understand this?
Yes, sir.
If you change the angle of incidence, the angle of reflection as well as angle of refraction will change. Do we understand this?
Yes, sir.
At one particular angle of incidence, the reflected light, this one, the reflected light is completely plane polarized. This angle is known as polarization angle or polarizing angle and is related to the refractive index of this material. The refractive index of this material is mu. Tan of angle of polarization is mu, and this law is known as your Brewster's law. So basically, what is Brewster's law saying? If the angle of incidence is the polarizing angle, your your reflected light will be plane polarized. Your reflected light will be plane polarized, whereas your refracted light will be partially polarized. Remember, we cannot polarize the refracted light, but we can polarize the reflected light. If the angle of incidence is polarizing angle, the relation between polarizing angle and mu is tan of polarizing angle is mu. This law is known as Brewster law. This law is known as Brewster law. Do we understand this?
Yes, sir.
I will give you a minute to note it down. Well, just to add, let me complete this entire thing so that you can note down everything together. In case of oops, wrong color. When we are having the angle of incidence as the polarizing angle, so when theta is equal to polarizing angle, it's written wrongly here. Just make it reflected light is polarized. Do you understand? Reflected light is polarized.
Yes, sir.
Reflected light is plane polarized and refracted light is partly polarized. Do we understand this?
Yes, sir.
One more thing you must understand, that when the angle of incidence is polarizing angle, reflected and refracted rays are perpendicular to each other. So this angle is 90. Two conditions you must remember. First condition is if the angle of polarization is IP. If the angle of incidence is IP, then the reflected light will be plane polarized, refracted light will be partly polarized, and reflected and refracted light will be perpendicular. Two very important conditions. Can you remember them?
Yes, sir.
The third one, if the angle is less than or more than polarizing angle, both reflected and refracted light will become partially polarized and the angle will not be 90 degrees. Angle will only be 90 degrees when the angle of incidence is polarizing angle. This is what you need to note down everything about Brewster's law, and I'll give you a minute to note it down. Well then, I move on to my favorite part, which is the question and answer part, and here comes the first question. What do you mean by, what does polarization of light prove? A, B, C, D. Which nature of light is proved by the polarization of light? Transverse wave nature, longitudinal wave nature, quantum nature, or corpuscular nature of light? What is the correct answer here? You might be confused. It tells us the transverse wave nature of light. Transverse means the direction of propagation of light and electric and magnetic field are perpendicular to each other. Will you remember this? Yes or no?
Yes, sir.
Yes, remember this. One more important information that you must remember is the Brewster angle for glass and water, because it might come to you as an information wala question. So just note this down. For glass, the Brewster angle is 57 degrees, and for water, I'm saying Brewster angle. For water, the polarization angle is 53 degrees. Can you remember this data? It's not given in the sheet, just note it down. Okay. Have you noted it down, beta?
Yes, sir.
Well, then comes the next question, and tell me the answer to this one. The angle of incidence at which reflected light is totally polarized from reflection from air to water. Refractive index of water is N. What is the correct answer? A, B, C, D. Which one is the correct answer? This is question number 3 from your sheet.
Sir, D.
Sir D, Sir D, Sir G, and Sir D both are correct. So I will give you that. Remember, tan of angle of polarization is equal to mu. Do not forget this fact. I hope you will not forget it. Question number 4 comes on your line. I hope you can give me the answer for this one. Which one is the answer for this one? The polarized glass used in sunglasses is fashion, reduces glare, cheaper, looks beautiful.
D. B.
Yes, you must be knowing this. It is B. It is used to reduce glare, and I hope you can understand why it is used to reduce glare. It's a polarized. It's a polarized. It's a polarized glass. Next one. Next one. Next one. Next one. A polarized is placed at an angle of 45 degrees to an incoming light of intensity I naught.
B.
Wow, well done. Do not get confused, because the first light is unpolarized light. After polarization, the light becomes I naught by 2. This was I was telling you many times that you must remember these simple facts. One more, all the other questions are I think repeated. So one more that is remaining, and here comes this one. Here comes this one. A ray of unpolarized light is incident on glass plate at the polarizing angle of 57 degrees. Then A, B, C, D, and I'm waiting for your answers. Which one is the correct one? Read the options correctly and then give me the answer. And the answer is
B. B. B.
BBB. Reflected ray is completely polarized. Transmitted ray will be partly polarized. And here we come to the end of this particular topic. We are done with polarization. We are done with polarization. We have seen what is polarization. We have seen what is unpolarized light. We have seen that in unpolarized light, light is propagating in this direction and electric field can move in any of the plane ka perpendicular direction. If you put a polaroid with a transmission axis, only oscillation which are parallel to that axis will pass through. Such light is known as plane polarized light. The intensity of plane polarized light is I naught by 2. If you put another polaroid that is known as an analyzer, after the analyzer, the intensity becomes I cos square phi. Do we understand this? Do we remember this?
Yes, sir.
I'll give you 5 minutes to go through this entire thing, and then we will do a quick revision of the entire wave optics chapter. 5 minutes, go through this, And then I will be back with the next lecture on quick revision using your mind maps. So you have time. I'll see you on the other side. Take care.